my first question was for OpenEV. Could it be that my files are too large because I got errors when I was trying to visualize them?
Okay, good point. Okay, so there are, yes, I think if they're overpassing the 4 giga, OpenEV is giving a problem, so it's not able to read the big GeoTIFF file.
I'm not sure if they are.
Okay, check this one. Then there are some cases also the compression. There are some compression that are not readable by OpenEV. There is one that is the interleave band or predictors in the CO. So if you can you do a GDAL info of the TIFF?
Yes, let me try that. GDAL info. Oh,
share the screen.
Yeah. No.
Anyway, sometimes also if you have some NA or very floating 64 very big, sometimes you can have some OpenEV is not able to read, but it's not. Try to with QGIS, you know.
Yeah, in QGIS it did work actually.
Yeah, so don't worry, because sometimes, I mean, it's very old software OpenEV, so there is not an update with all the, you know, compression algorithm and so on that has been added in the last maybe 10 years, 5 years. So good point, but don't worry too much.
Okay. Yeah, that I don't know how important it is to get into, but so this is what I get, right? Just a black screen, and there's an error somewhere.
No, but, wait a second. If
oh, there's all no data.
Image, yes, bravo, is on all no data. Or maybe there are just few pixels.
Yeah, so, maybe it's just few pixels, yeah.
So get an histogram of that one. So close it, or a minimum maximum. GDAL info -mm. Yeah, enter. So it's byte. So even if it's big, it will be able to read. Yeah, it's computing though, because
okay, so it's right.
It's computing, yeah. The minimum maximum, I mean, is reading the full image, you know, to check.
Oh, they're all one.
Yeah, there are few minimum maximum. I mean, you have 0 that is labeled as no data, so, and you could see that is in the course when you were moving the image. Then you have just 1. And then maybe you can even check how many you have it of that one with the PK start histogram. So PK start space --east, and then -I for input, and then the name of the file.
Oh yeah, of course.
Okay, enter. So this one will give you, you know, two row, yeah, 0 and 1. So you have few pixels, I mean, quite a lot.
Yeah,
so
I do have some. Yeah.
So open it again. So maybe it's just a stretching. So do it again, OpenEV, and now press the, you know, the one on the left. Yes, one of these.
This one.
Yeah, sometimes it's just a matter of trying.
Ah, okay.
Here you have it. Okay.
Okay, that's actually how the file is supposed to look like. Perfect.
Yeah, perfect. Yeah, of course, if there are just for everybody, if there are maybe 2 or 3 pixels, maybe you will not see them because they are so small. The matrix is big, so will not need appearing, you know. So always double check with the histogram, with the minimum maximum to understand what you have. Okay, very, very good, Martin. Anyone else in this line of data set that is trying to testing? Yeah, you can stop the sharing just in case someone had.
Yeah, I'll let someone else. I have more questions, but I can wait.
Okay, let's see if someone else has some questions. Okay, if not, Martin, you can continue. In the meantime, the other can think some question. Oh, now you are on mute.
Oh, thank you. I have a file with a, what is it, .mdb extension.
MDB.
Yeah.
Yeah, okay. Did you Google it?
Yes. So I don't have a GDAL driver for it. Is that like, can I install them, or do I have to use different software, or?
Okay, okay. I never see.
Yeah, me neither.
Could be that is not installed as a default, you know.
Because there is formats. Oh yeah, but yeah, when I check the GDAL formats, I didn't see it in there.
Perfect. Yeah, so okay, MDB drive is an alternative way of reading and 3 personal. Yeah, could be that you have to Google it a bit how to install it. Anyway.
Yeah, Microsoft Access database. Someone mentioned it in the chat, and Windows also tells me that that's what that is.
Yeah.
I think I found what you might need. Post it in the chat.
Oh, thank you.
Oh, great. Yeah.
Perfect. I can
could
look
be
into this.
Sometimes you even maybe you just install another package. Like for example, the netcdf, if I remember correctly, is not as a default. So then you can install the netcdf GDAL add-on, let's say, and is going to be able to read it automatically. I remember that maybe now is the geodatabase from ArcGIS, no? NDB.
Oh, maybe.
As the personal geodatabase. So could be that should be able to find a way to open.
PGO. .mdb. Oh, okay. Oh, well, thank you. And then I think for that one I should share the screen. I think it's not a huge issue, but I would rather double check. So I have this TIFF here, and it also has some auxiliary files with more information. And then I get this warning here telling me that they don't quite agree with each other. This one here, the definition of the projected CRS 3035 is not the same as in the EPSG registry.
Okay, I would say where they come from. And actually, this is a warning that it was coming up recently. I start to notice it also in the last year. So it's a warning. So quite often the warning, you can skip it. So it's a bit of a matter of interpretation about what is going on over there.
I think it's not a big deal, because when I looked for this specific string on here, I get to exactly this one. So it seems to be the same one. I just wanted to make sure.
Yeah, this is the typical 3035 is the typical LA projection. Yes, ATSR LA projection. Can you go back to the terminal?
Oh, to the terminal, of course.
No, here is
fine.
Yeah, this is the one that was adding in the last year. I started to show recently, and actually I have to say the truth that I also ignored it as a warning because I was sure about my my source of the file. So maybe we need to double check what is going on and why. Anyway, say that it is maybe cows issues during the reprojection. So if you are not reprojection, maybe it's not something that you can ignore.
Well, I want to reproject other files to this. This is kind of I would like it to be my base raster.
Yeah.
Because for my project, I have a bunch of these forest layers and I want to create a hybrid map. And this is kind of my target.
I would say read a bit about these new issues. I mean, this warning, and you have in all of them. And double check if there is any information useful to understanding if we can just ignore it or not, or to fix it. And then concerning just few words about this other file for everybody, this TOVR is they say OVR as an overview. Okay, the overview are a sampling of the image and are able to have a fast. Can you scrolling down in this window? Yeah, down. Yeah, perfect. So you can see that before the metadata, you can have a different overview. Okay, so these are nothing else that a nested TIFF, let's say raster inside the raster with different resolution, and are useful just for faster rendering in maybe in OpenEV, no, because it's old software, but in QGIS and so on, yes. So it's allow you, when you zoom out, you don't need high resolution. Okay, so rather when you zoom in, allow you to have a high resolution. It's very good for fast rendering in QGIS and so on, and is also good for the so-called cloud optimized GeoTIFF that are also useful for web GIS rendering. So whenever you work with a WebGIS with a big data set, let's say bigger than 1 giga, you start to having issues in the data rendering, so that is not faster rendering. Okay, so the user need to wait until all the images is rendering back. So using this overview and the COG are useful for this kind of application. Of course, it's something that you build the overview, and you can Google it. I can give you also the command how to build the overview. Is useful just in the last TIFF of the processing. Okay, you don't need to build overview in the middle, of course, and also because every time you need to rebuild, of course, is inside to the GeoTIFF. So actually can be can be inside or can be outside. Okay, in this case is now can you go back again, Martin, in the top? You can see that the TIFF is that you have the TIFF and then you have the TIFF OVR. So that OVR file is the resampling raster file. Okay, it is attached to it, but just by the name. Okay, nothing else. Actually, if you remove that file, then the overview is gone. Okay, rather sometimes they can have inside the GeoTIFF and you don't see unless you do the GDAL info, you see overview over there. Then the other one, the AUX XML, is something that that one you can remove it.
Okay.
Actually, I never understood why. There is sometimes OpenEV, sometimes QGIS created, and then sometimes also some GDAL output created. Quite often I remove it because also it's very small and can be recreated if a software needed. That one is not really important. Okay.
And then here in pixel size, we always have, is it?
Yeah.
Why is it
negative?
Is it always negative, or
this is something, this is something that we need to ask to next lecture. There is Francesco Lovergine, and let ask to him, because there are sometimes it's negative, sometimes it's positive, and I never understood why the true. And with GDAL edit, sometimes it doesn't accept the positive, you have to put a negative, but I didn't understood very well the why sometimes it's different. So let's ask him if he has some input on this.
because I have, so there's a different file. This is a vector file, and I want to rasterize it, and for that I need to specify the pixel size. And with -100 it doesn't work. So if I put a minus here, maybe I would need to
perfect.
put it in quotes or something. I'm
no,
not sure.
No. Sometimes some software, yes, some GDAL command they don't accept it. But then you see in the output. So it's something that is always a bit tricky. And frankly speaking, I didn't understand if there is a rules and which one is the rules.
Yeah, similar for the NA value. It's also negative in this case.
Okay, that one is something that we discussed. It can be is just a label. Once again, it's just a label. It can be any number.
No, I get that, but so this one is actually edited, and I edited to
Perfect.
48.
Right.
Perfect. But then it writes it as -48, which I mean I don't care. I was just surprised because I think in the actual
because you put in the dash.
Oh, I don't need the dash. It's like this.
Yeah.
Oh, I see. It's not a command. Yeah, of course.
Yeah.
Of course.
So that one is negative because you put the minus. Yeah.
Okay. That clears it up then. And yeah, I mean, this file, it was actually, because it has originally was 128, the NA value, but in the documentation, there are values of 48, which are actually the NA values. So I have two kinds of NA values. So I had to recode them.
Okay.
To just have one. But yeah,
perfect. So can you go, let me say something quite tricky. Can you go in this directory and do an ls of these files?
No, let's not do it here.
Yeah, also there is fine, whatever.
Well, I have already the path somewhere. So this should be. No, one more. Which one is it? CLC. Oh, one more. Yes.
Okay. So something also quite important to remember is that these AUX XML also contain the statistics that you see in the GeoTIFF metadata. So can you switch back? Yeah, perfect. So if you're scrolling down, this information over there, and also this one, minimum, maximum, where you have the standard deviation. Yeah, that line. Okay, be careful. So if you change the file, that file is the old one. Is not overwritten. So when it's going to ask in the statistics, it's going to be giving you the old one. So that's why I also remove it always. Okay. So always be careful about this situation, because and once I discover it, I say, come on, I change it, should be changed. And then I discover that the statistic is not updated. So whenever you see these statistics, the word statistic and this long minimum maximum with standard deviation, that one always means that there is this AUXML somewhere. Okay.
Yeah.
And it's going to that one. So that one, and actually it could be, okay, in this case, it could be that you have the minimum maximum, where you have the two lines with the minimum maximum. The first one, mean and max. So the first line. So yeah,
here.
No, that one, is the GDAL info information. Rather, the following up is the statistic in the XML. And sometimes you will see that it will not match because you change the input. Okay. So always be careful about this situation.
This information is not always there, right? The minimum maximum. I feel like
it actually should be there when you ask. So means that also that one, try to remove this XML and asking again the GDAL info should be gone.
Okay. Because it actually, like you said, these don't change. Like it actually, like I had to here recalculate it, and then it's not the same because this is just stored there, right?
Perfect, because if you remove that file, the XML, it will be gone, that line. So you can remove it. It's useless. I don't know why they always is out XML. They always build up. So not always, sometimes they build up. Okay, you would say yes, yeah. Now if you re-ask, the GDAL info should be gone quite often. No, it's still there. It's still there. Can you go back? Maybe there is another TIFF. XML, remove also that one, yeah. Yeah. Yeah, that one. Okay, now rerun.
No, it's still there.
No. GDAL info. Still in the metadata. Okay, if you recompute, will be fine. Like you say, will be fine.
Like with this line?
Yeah, with that one, every time if you put them are you sure that you are going to get the fresh one? You know.
Yes, and it takes a while because it actually checks the file.
Because it checks the full file. Yeah.
And is there then a way to update this information that it then has the true one? So next time I call it, I don't have to wait.
I don't know. In GDAL edit, I think there is one flag that says statistics for something. So maybe something that you should check in the GDAL edit, because GDAL edit you can edit this metadata, not only the no data, also the information. So for example, sometimes they have the author or the version of the TIFF, version 1. And so that one is, you can edit with GDAL edit.
And then I think I know the answer to this. So I had here, this is a vector file of polygons and a different projection. And then I wanted to rasterize it. And I was wondering, I would think that there's a correct order of operations, right? To first reproject. Like I'd rather want to reproject a vector file than a raster file. Is that correct?
Correct. Yeah, I would go first with the reprojection of a vector.
Yeah.
And then from the vector to rasterize. Yes.
Yeah. Intuitively, that felt like the right order. Okay, cool. I think those were all my questions. And then I can talk about what I did. I'm not sure how relevant it is, but if someone else has questions, that probably should take precedent.
Let's see if someone get illuminated by question of Martin question, and he won't say one. Samuel, maybe. Yeah, if you are trying to talk, you are on mute. Still on mute. Okay. Yes, now should be fine. Yes, go ahead.
Thank you. I have a question. Is that I was trying to download some of the tiles files from your website, hydrography. And then I can show you a screen real quick.
Yeah, go ahead.
Like I was just working on like, for example, just using this as an example, this is the stream slope.
Yeah.
And then so each TIFF is like a small area of the globe. And like, would you recommend the first thing I do is try to build a VRT and then combine all of the files together?
Perfect. Yes and no, in the sense it's depending what you have to do it. Okay, so you combine, the combined VRT should include all of them. Okay, so now when you point to the combined VRT, if you do a GDAL translate to it and so on, is going to read all this file. But this file can be maybe 20, maybe even 200 giga.
Yeah.
Okay, so it's really depending what you have to do it. Okay, so it's good to build up the VRT, but then it's not good to use it as it is for computing a new TIFF. okay? Especially so that combined TIFF, if you check, is going to be very huge.
Yeah, so I think I have a very hard time to open up the
Perfect. That is the reason. So you build up a very huge VRT when is really the last chance. So, you know, the last product maybe of a processing chain, and actually we compute the global TIFF, and they are 80 giga file. And with these 80 giga file, you know, you need to build up the pyramids, the overview that we say before, for just visualization. And they are not good for real processing, because if not, every time you have to wait a lot of time to do something. Okay.
Also, so better just write a loop or something to go through the...
Perfect. So the best way is, for example, let's suppose that you have to not crop it, but let's say, suppose you want to calculate minimum maximum of these. Okay, you do the PK histogram for each one, or the GDAL info for each one of the tile, and then you get the maximum of the maximum. You don't do the GDAL info of the combined TIFF. If not, it will take age, you know, and you will not. Okay.
And it's very hard to GDAL translate. It's very hard to GDAL translate the combined VRT to the combined TIFF. It takes a very, very long time.
A very long time, because it's a big file. Okay. So you really need to go in that direction when is the last output. Okay. But then what I suggest to you is keep starting to use it all single TIFF as an independent TIFF to do something. Okay.
If we want to draw a plot of a global, like a pattern, global.
Okay, so in case you want to do it a global pattern, or see what is going on at global level, this is for everybody. This is 90-meter file. So open a global level 90-meter file will be extremely huge and long. So what you do, you resampling first at 1 kilometer with GDAL translate each single tile, then each single tile 1 kilometer, you build up the VRT, and then you build up the TIFF. That one will be fine. And you can see the global, and that one you can see anyway the global pattern. Yeah. Okay.
That's because pixel is too small to show on the plot. The 90 meter is the same as the 200 meter. If you put on the plot, is that what is it like because the global pattern, we are not concerned about the small scale?
Perfect. If you need to see a global pattern of are all the TIFF in line, I mean, there is some strange pattern in the picture. Okay, then of course, if you need to zoom in some particular area, and then you need back the 90 meter. But what I always discourage is to build up a big TIFF. Okay, when I say big, try to stay below 1 giga. Okay, 1 giga, 2 giga start to be a big, you know, and then you build up like I did for this one. We have the global TIFF, the 80 giga, because user ask, but is the worst that can be done in this big environment. Okay, and going back, going in this direction, there was I was pointing a lecture on the use of XArg for multi-core operation. I don't know if someone of you have read that one, maybe you can point again, but that one is a good way to starting to use the multi-core operation for this kind of application where you have several TIFF all the same, and these files are really well standardized. Okay, so you will not find, or you should not find any, you know, mismatching, pixel alignment, or you know, each one is very target to the degree level, digit degree level. So they are very well assembled. So that's why I always say you need to very picky in this aspect, especially if you work with tiles. You know, if you work with one TIFF, okay, you don't care so much, but whenever you do it in a tile system, they need to be very, very well consistent, all the tiles. Okay.
Yeah. Okay.
So try to do something. Try to do something.
Is it just do GDAL translate to the higher pixel first?
Sorry?
You said it's a GDAL translate and make it a larger scale first for each clip, right?
Yes, because you can point the VRT, the combined VRT is fine, but then when you do the GDAL translate, you can create the 10 by 10 pixel, so the 1 kilometer, and that one will be very small, and that one you can open and see what is going on. Okay.
So it's either like I can combine first and then resample.
The combine is not an issue. The combined VRT is not an issue. Okay.
Okay. Thank you very much. And I have one last question. Is that
yes, please.
For like unc files is exactly the same as the TIFF files, right? All the like.
Sorry again.
If I download the unc files, if we encountered
NC,
like
NetCDF, NC. NC file.
Translate it first to TIFF and then
compute. Yes, you remember the last time there was, I think Marty was asking about an NC file that they have this subdirectory, substructure like the HDF file. So you have to be carefully how you read this NC file. And then for people, maybe for everybody, people more in the climate field, NC file are very used for climatology, so temperature, precipitation, and so on, water pressure. There are people for climatology. And there is an additional package that is called CDO, Climate Data Operator, made by Max Planck Institute, that you can install it. That one for NetCDF is really wonderful because you can build, they have a lot of modules in the data cube, okay, because they're working with day of temperature, for example. So you can build up a spline or regression through the pixel and minimum maximum through the time, and so that they have a lot of application and is built up directly in the bash, and it's super fast. So I use it a couple of times. So if you need to do some climate operation in NetCDF, think to read about this CDO, and you will get very fast because it's bash based. So in a couple of days you can master the most important part, let's say the easy part.
Okay, thank you very much.
Welcome.
I should stop the sharing here.
Yes, and sorry, can I also ask one small question?
Alex,
yes, regarding this, if you have such kind of situation with a lot of TIFF tiles, and we want to make to calculate some global model, like for example, to select all the slopes which are less or more than a certain degree. So to recalculate it to 1 kilometer resolution is not an option here, because it will modify all the data, and it will corrupt it. So what is the best option in this case? Can you for example, use these VRT files to calculate this, for example, globally, to select some value and like this?
Okay, it's really depending what you have to do. Of course, the one that was mentioned to resampling at 1 kilometer resolution, that one can be can be a way to avoid to open the 90 meter for visualization. But let's suppose that you want to check. Yeah, this is a good point. Let's suppose that you want to find out if there are very high value, so maximum value in your raster, in your tiles, let's say in your tiles, and where these maximum value, they are located in the globe, okay? So if you do a resampling and you ask the maximum of each single 10 by 10 pixel, you get the maximum of that 10 by 10. So when you are going to aggregate the 1 kilometer resolution, the 10 by 10, you will see the maximum of each single 10 by 10 pixel. And then you can see and open and see where they are, okay? So this can be a solution for this kind of course, you have to think what do you is your need? I mean, how you have to manipulate your TIFF to get your what you want. For example, in my case, for example, that I was working with the digital elevation model, and I need to select the basin. Okay, so the basin of each single stream. So if you have a bit of hydrological background, the basin is delineating where the water goes, and the water where it goes in the minimum point of the digital elevation model. So in my case, it was the opposite. I could resampling at getting the minimum of each 10 by 10. And then now I have a globe 1 kilometer pixel, and I can calculate my basin. Okay, of course, the border will be distorted. Okay, because of course it's not the same to have 90 meters and 10 by 10, but then I can see where they are, the macro basin, where are located and so on. So then I could buffer around it to have a bit more increment and precision, you know, and then I can work in that area at 90 meter resolution. So you have to always to think how you can get, you know, how you can, what you have to do. Okay, so in this line, let me point again this xarg. Let me share 1 second the script. So I was pointed last time this screen. Oops. Yeah, so can you see the screen? I think so, no?
Yes.
So this one over here, in this one, you have the bash, and then you have the multi-core operation. I don't know if someone already, because I mentioned last time to get, I mean, to read about this, and I mean to read, and you know, there is a video lecture over here, and Kier is explaining how to use it, multi-core operation, using different tiles, where each single tiles go in a CPU for doing something. Okay, before it build up a simple loop, and then can tell you how to do in each single tile to do something. Kira was doing just a GDAL translate, but then you can do whatever you want. You can do map calculation, you can do whatever you want. So that's why it's very important not to create this macro TIFF, because you want the tiles, because you are able to do the multi-core operation. Okay, so you want to keep the tiling system as much you can. Then there is, of course, there are some cases that you cannot do it. Okay, so for example, one of the cases in most of the time, when you have the tiles, you have border issues. I mean, tile border issues. For example, if you want a moving window analysis, on the border will be subject to because it's missing the other side. So what you do tiles that are in overlapping area. Okay, so you have your tiles, but then you do 10 pixel on each single border to include, and then you do the moving window, and then you recut back to your tiling system. So you have to think how to do it, but it's possible to do all these aspects. So let's do like this. Let's this one, everybody have a look for next and follow this lecture, and implement it also for your study case if you have it, and then we can discuss deeply on this one. But are you anyone, maybe Martin, because I think you were asking about this last time you were watching this video or not?
Sorry, what was that? I was trying to install the driver.
Okay. If you are watching this video about the multi-core for loop in multi-core, because I think I point to you last time. But anyway, for next week will be a good opportunity to read about this. I mean, to listen this video lecture and use the system, this application for your case. Mm-hmm. Okay. Okay, cool. Any Any other question in this regard about personal, let's say personal data set analysis, or maybe even personal frustration in doing something? It's not coming out. It's normal. It's normal. Everybody can feel dumb sometimes. No problem. No shame.
I maybe have a short question.
Yes.
I hope it works because I'm like with the video and audio, I'm on my computer, but I have the stuff on my laptop, but I try to share my screen on the laptop. It was just about I think there was a small section on installing something in R in this temporal interpolation notebook that we should go through as like an assignment where there was this video recording. And there I'm just getting some notification on being asked if I'm sure to install it in a certain folder, and then it says it doesn't have the like some access right issues, I think.
Yeah, I think they are in that exercise are just for making the plot, if I remember correctly. So it's not a big issues. Anyway, we can go through through the explanation to see also if it's clear the system. I mean the method that we implemented, because that one is a good example how to deal with this in combination of GDAL and PKTOOLS.
Okay.
But let's address it first, the assignment that we did 2 weeks ago, and then we move to the temporal interpolation.
Okay, so should I skip the question for now?
Yeah, let's skip the question, and then we will review it today, and having a kind of discussion on this. Okay, anyone else in this personal data question, let's say? Okay.
I also have a short question.
Yeah, please.
So if I want to read every pixel info into a NumPy array, is there any benefit of using VRT, or is it faster than reading like an actual TIFF?
Okay, yeah, good point. So I would say unless the VRT is pointing to multiple TIFF, like a combined VRT, then it is good you are going to read all the TIFF that VRT is pointing. But if the VRT is just a VRT of one TIFF, probably is useless.
Yeah. So say if my real TIFF is like 22 bands.
Okay. Yes. So the same is your VRT is 22 bands, and the VRT is pointing to 22 independent TIFF. Okay, then be careful, because be careful that pointing to the VRT is going to read as an NumPy array the full 22 band, unless you specify I want only the one. Okay, so the VRT is just a pointer that can be a spatial pointer or a multi-band pointer. Okay, so if you point to the VRT and the VRT is globe, but you work only in Australia, so it's going to be a bit useless to have your point to the VRT. Okay, always check with the GDAL info what include in the VRT. Okay, and then see if it makes sense or not. Yeah, good point. Yeah. Anyway, all the Python will be the Python application with NumPy will start next Thursday with Francesco, so we can be ready to smash him of questions. He's very good. Okay, so let's move to the assignment, because I think to the GSIM assignment, I think everybody is curious to see a potential solution. So so I shared the screen. I open all the notebook that you guys sent it, and you have done quite good job. I mean, everybody tries. So this is the most important. Oh, okay, not everybody. Let's say 1/3 of the class. So it's good that you try, because by trying you learn it. So this is the most important part. So I make the assignment over. I pasted it, yes, the solution of the assignment in the syllabus. So if you're scrolling down, you can see here you have solution 1, solution 2, and solution 3. Okay, so then and then I also create an Emacs file, I mean an SH file that we can use it directly. Okay, so so how we are going to use it? So if you go to the VirtualBox, okay, so now we can use the typical the Git pull to pull from the node data. So now we have to see if you make mess or not, in the sense. If you are in the home and you do Git pull, actually SE data, like is written over here, SE data, okay, and then you do Git pull. Maybe I also make a mistake, because in this directory, if you have conflict, if you have some conflict, means that you were doing something in this directory. Okay, so rather, if you do the Git pull, should be able to say, okay, you can download it, you can, is downloading this new file. Okay, perfect. So at this point, you can run the rsync, okay, to synchronize whatever you just downloaded with the new, with the rsync in the new directory. So if you get some error over here and you say something like, the synchronization doesn't work or something like this, means that you have to remove all the C data folder and redo the git clone. And in particular, this is written over here. If for any reason the git clone command gives a synchronized error, then you need to remove this SE data. And now you do it by removing this one and redo it. Actually, I didn't put the git clone over here. No. Yeah. Yes, I didn't put the git clone over here. And you have to redo it over here, the git clone. But maybe it's fine for everybody. Okay. Anyway, if not, you can just follow also here this one by by reading over here and so on. So so let's go directly in the GSIM explanation, and you can see the email over here, GSIM dataset. Open tab. Okay, so now a bit below here. No, sorry, here. This one. So now I'm going to copy this folder. Okay, sorry, not this folder, this script to the directory where you have it. And everybody should have under this directory the CD folder. And if you don't have it, please changing accordingly. Okay. And you can copy in this directory. You can copy in this directory the file that you just downloaded. Okay. So now we have this file, the manipulate GSIM assignment solution SH, that we can open. Okay, so you can open now. Let's use Emacs. In this way, you start to appreciate the use of Emacs, and you put the end in order to have the terminal for you ready. Okay, so now that is open, you have this new window that is popping up. And again, this script and nothing else than the one that is over here under the assignment area. So you can, if you don't find, you can follow by here and try to understand what is going on. If you remember, the assignment was to try to create a file where you have for each single year, months, a table where you have the station, the lat long, and also the mean. Okay. So there are different solutions to do this. I get this solution from last year, and also a new one from this year that was coming to my mind also, thanks to your input, guys. And in particular, so over here you can see for making the script a bit faster, rather than do it the full United States, I do just a selection of 100 station. Okay, so here you have different way to do it. Okay, so let's see the first one. Over here you create first a text file with all the dates, and how we knew that whenever you do some AWK to this file is going to read all of them. So actually you don't need to loop between, do something here, do something here, do something here. If you are able to do something in all of them all together, then you don't need the looping procedure. Okay, so over here what do we do it? We print if everything is all the field and number of field is bigger than 5, and $1 is bigger than 1, print. And this way we get the dates. So over here we run this line. Actually, this one also learning this. If you put an exit here, you can run directly this script, and it's going to stop over there in the exit line. So you can do bash manipulate. Okay, so now it's doing only this. Actually, why is it not getting? Maybe
do you just save the file or something?
Maybe I didn't save it. Yeah, bravo. Okay, perfect. So now it's going to be use it only this one. I mean, compute it. Okay. So as you can see, is fast. But okay, I'm not doing a full data set, just a part of it. And now I have a file that is completely my dates. Okay. Now I do perfect the same, but rather than do it, I'm grabbing some particular GSIM, and let's do for one file. So over here, if I grab for one file, you see US_0. Yeah, probably one, no. 18, okay. So this one is going to give me for each single file one particular line, okay? And the same if I do the same for that file, the longitude, okay? If I do the longitude, it's going to grab again the longitude. Okay, at this point, I can do, I can paste this information together. So if I paste this information that I did before, this one, I'm going to have this information plus this information all together in the same line. Okay, so I will have this one, the station ID, the lat long, then I will have the second one. So now let's remove the exit over here, and I do exit here. As before, remember always to save it, you can do Ctrl+XS to save it. Then you go here and you do bash. Okay. So now it's doing also the second one. So we can open this output. So LL output 1, we will have just one file, and we have also the output ID. Okay. So this one is what? Is just a table with the lat long information, sorry, the station, and then lat long is information. Okay, so now at this point we can loop through the dates, so the file that we created before, and for each dates we can get the dates in each single file, the line. So let's suppose that we have, let me get one date, and this is how you also try your command. So let's suppose that we have these dates. I can say dates equal to this. So at this point, if I do grep starting with, this is the meaning of starting with all my file, and again check out that I do the grep for all my file. Okay, in this case there is no any information, there are or NA, and actually this one is going to be eliminate, let's say not consider it, because $3, if my $3, so you count one. Actually, this one is going to be my second column, because this one is going to be substituted by space. Okay, this one I also get rid of my CD by this one, substitute my comma with space. So my $3 is becoming NA, and is going to be first column, second column, and third column. So at this point, let me get another date. So let's do this way. We have the number tail. So let's do this one, and I do Control R date equal to this one. So now still yes, okay, so now a few of them do not have NA, and some they have the number, and this line is going to get rid of NA and printing only this number over here. So now if I print a full line with this date information, so let's see, we can have one file that is going to be only my file. Okay, and I can do head. I can have my station ID plus my mean. So in other words, I'm getting this one. Okay, perfect. So and the 92 yes, is just right over here. Look, okay. So at this point, I have this information. I just need to combine the information base on the ID X and Y plus my new mean. And this operation I can do by a join operation based on column number 1. Okay, first file column number 1, that should be the ID, and first file column number 2. Be careful that whenever you do the join, the two files need to be sorted in the same way. That's why over here is sorted, and also that's why over here is sorted. Okay. So pro and cons, and now we can run this loop. You can do exit. We put exit over here. Okay, and we can see Control R bash. Okay, so now it's processing each single date. Okay, and so it's doing the for loop, and in particular, it's very good always to put a printing of the variable in the for loop. In this way, you know at which point it is, you know. So it's okay, it's going. Okay, you will see that there is something faster. Why pro and cons of this one? Okay, I think it's quite understandable in terms of syntax. What is going to be a bit slow, that, you know, we are looping through each single file several times. Okay, in particular for each date. So we read the file over here, we read all the file once, another time here, but here we are looping each single file several times. Okay, and also the join operation is fast, but, you know, every time he has to match the two files together, so that one can take a while to do it. Okay, On my machine was a bit faster, rather on this machine, the virtual machine is a bit slower. Okay, in the meantime that this one is finished, let's see if anyone has a question on this. If something is clear or not. Or also, if you have done something similar, I think I saw one of you using join. Now, I don't remember. There were like 15 exercises. Okay. Okay. Meantime that this one is looping, let's check the second one. So this one is doing what? Is going in a for loop immediately in all the file. So doesn't read the file twice. It's just entering in each single file and does some operation. So he creates some variable based on the position of the GSIM, lat long, and so on, based on that one, for each single file, okay? Then he make a directory to be able to store the file a bit easier, okay? And then he is going through each single variable, he importing in AWK this variable, and then is creating the file each time. So in other words, for each file is going to split the file in according to this operation. Okay. I think you will understand this one when we read this one. That is much easier to read. So let me stop this one because it's also quite long. Okay, it's almost finished. So before to read this one, let's go to this one that is the third solution that also Olivia find out, and is one of the most elegant, elegant and really simple, and is using a particular function that is built up in AWK that is able to split a file based on some ID that is encountering inside to the file. So what is doing this one? This one is okay, first of all, is using the full file. There is no any loop. By using the full file, this one is becoming like a full file where I can do some operation. Okay, if $2 is equal to GSIM, then station is equal to $4. Okay, so this one is just doing, if my column, and if you remember let's take one of them. US, yeah, this one. So if I take one of these, you remember the structure of this file that will say that my column number 2 is equal to GSIM. So if is equal to GSIM.no, print $4. So this one is getting to me this. Then the latitude is going to be this one, and the longitude is going to be this one. Okay, so far, and this is always the same. Okay, this is always the same, not only for this file, but is also for the other file. Okay, due to that, these two files are perfectly the same. When I do it like this, is going to be, is going to do it for the full file. Then there is also another condition that tell me, if my $1 is a number, and actually this one I have to say thanks to Martin that showed me this syntax. I found out if it has this syntax, this one in particular, 4 number going from 0 to 9, and then a dash, 2 number going from 2 to 9, and another one from 0 to 9. Okay, and $2 is not equal to NA, so he's avoiding this one. Then he does this operation. Okay, it's printing the 4 information. Okay, all this one, perfect. So now he does this. Okay, he's splitting as a function of this one. And this one become, actually not a full this one, but just this. And this one become my ID, my file name ID, let's say, okay? So in other words, it's go through the file, every time that find one line with this information is going to be split immediately to other file, okay? And this one was, mentioned in this page that I point to you. Of course, it was in a simple format without all the GSIMs on, but this is where he was pointing. So if we go, I think a pasting matter most, 2023. Yeah, so this one in particular, it was the second, I think was the second. No, actually the third one. So split the file by having an extension of it to the new file name, in particular what? Using the $1. So $1 is going to be each single row. And every time that is encountered a row is going to be added to over there. Okay. So in other words, I'm going to print $1 is going to be this one, 1 and 2. Okay. Sorry, here is, 1, 2, 3, and 4 and 2. And here is going to produce 3 files, item 2, item 1, and item with inside each this one. So in this way, the for loop is already built up inside. Okay. So this is where when I pointed to this page, we were going to get this information and expand it, adjust it, but this is the meaning. Okay. So try to always find something simple in internet that let you understanding what you have to do it, and then implement in your case. But I have to say the truth that this is a really typical feature in AWK, okay? Able to split in different file based on an ID. I don't think in Python you can do it so straight, okay? So maybe you can do it by looping and so on, but I don't know if there is some easy operation like this one. So this is how we are doing, okay? So if we go back to the example, it's perfect the same, but okay, perfect the same with some if condition in the beginning. Bigger. If condition in the beginning, but this is how we are doing. Of course, we are putting also the output, the directory, and maybe also the name over here, just to give a bit more extension. And this one was the same over here, but here we were looping through each single file. Okay. The guys that implement this one can use this technique, but he didn't know that he was looping each single file, but here we can give the full file, the full files, plural, okay? So this one you can see, so let's see the second one. So in order to see the second one, the only way to do it is, maybe there are also other way, but is just commenting all of them. So you can comment it. Comment region. Okay, now all these one are commented, so they are not going to compute it. And we can do the first, the second solution that is looping through the file. You will see that is already faster than the previous one. Okay, so you can see that it's going much faster than before because it's not, yes, here is looping because there is some, but it's not an issues. Is looping through the file, okay? So here, the last one is the 100, and you can see this one is already over. Did already the full data set. It was just a couple of seconds to do this one, okay? So this is where you really see the advantage of doing this in particular. And here you can see the real, you can really, you can, maybe we can even do it over here. You can even see the advantage by over here. You can do even in the virtual machine like this, okay, the full data set in this way. will take a while, but it's doable because actually it's going to do it immediately row by row, so it's not filling up the RAM and so on. Oops, sorry. Okay.
In the third solution, how are where are the headers created for the files?
Yeah, good point. So Olivia find out, I found one solution and Olivia find another one. So Olivia, she did perfect the same, and she create a file with the same name just over here, but rather than just printing the header, okay, with the same solution. And over here we just, so in other words, she was doing something, she suggests to do something like this. I don't think there is a better solution between mine and Olivia. They would be pretty the same. So she was doing something like this, print the header. What was, okay, let's leave it. Oh. Yeah, let's say the header, this one, I don't remember. I mean, this one will be the header, okay? Even if it's different from what is written, but the concept is important. So she was proposing this, but actually you have to, you have to loop through all the file twice, okay? And here you have to be sure that you're going to do it double, okay? So in other words, this is going through all the file, but just printing an header. And this one is going to do the same, but rather than printing the heading, appending to the file that has been already created and do it. Rather, in my case, in my solution, I was just doing afterwards, was doing a for loop and do cat, let's say header.txt file with this one, okay? So I was doing perfect the same over here, dates, actually, $file. I was just creating an header before, and then actually, I don't know which one will be the fast one, but they will be very similar because the cat is very powerful, okay? So over here, for file in $months. Actually, not in $months, in this one. In the output txt file anyway, if you understood. Okay. So I don't think there is another solution that you can do it by reading the file only once, because both solutions reread the file. Maybe it's a bit faster, this one, because this one is a bit of for loop in any case, so it will be a bit faster.
I think my solution was similar to Rosie's, and I figured if I have a way to check if a file exists already.
Yeah, but you have to do inside. Yeah, I thought the same. You have to do inside the AWK.
Yeah,
so
that checks every line. No, yeah.
Yeah, because if you print as a beginning, it's going to print only with the first file. If you put inside here, it's going to do one yes, one no, one yes, one. So it's really the way somebody was using the get line. There is one command that say get line. Maybe through that one, but I'm not sure. Anyway, both solutions are fine. Probably this one is the fastest one rather than this one. Anyway, you can see really the improvement, going from the previous one, second one, and the third one that is very fast. Okay. So and then is a matter of how much hour you want to spend in to improve the speed. So always try to get a balance between the two. So whatever you have, it is sufficient, then move to the second step in the processing chain. Okay. So I would say leave it go back to your assignment, to what you handled, and once again, the solution are here, and try to compare and understanding better, maybe even by rewatching the recording, and see you are closed or not, and you were catching some part and not some other. You know, it could be that you come out with a solution that is a bit a mix between the different one. I don't think I open all of them, and more or less they were in the same for loop through the file and so on. So it would be slightly different, but these are the three main solutions that are possible. Could be another one, but will be pretty similar to this one. Okay. Okay.
Could I maybe ask a question over
Yes,
here?
please. Yes.
So in my version, I used egrep in Bash, but
Yeah.
I couldn't do the same thing with AWK. Is that possible in some way?
The grep?
Egrep, that is with regular expression.
Ah, okay. I'm not yeah, so you did something like this, you know, with expression over here, and actually I think there was, who was, I think Martin or no, Olivia, maybe Olivia. There was, yes, I think I have it. The Olivia, she was using I think I have it here.
Yeah, I think
Yeah.
I did that.
Over here, she was, yeah, she was, no, actually, yes, no, this one is the same. There was somebody else that was, say, $0 starting with, and there was some syntax, now I don't remember who was, like this, home, and then starting with, maybe if he's here, he can speak, starting with, and then give us a 09. So this one, you know, was going to say regular expression are this one inside starting with the 09 and so on. So that one was making the full script. This one very, very short in this part over here. Okay, rather than writing everything, you know. And so I don't remember who was using this syntax. Maybe you, Martin, no?
I had both. I don't know which one I had it in. I have to check.
I think you were, yeah, I think you were doing this one.
Yeah. I liked it better because it's shorter.
Yeah, it's shorter. Yeah, and actually, so probably not all the regular expression are possible inside AWK. You need to check. But or if not, play with the substring, so a combination between substring, and then you select the substring and then say equal to something, something that you need to check it.
Okay. That was one
so,
question. Another one was if you have to use xargs, would that be an idea? Because then you're having multiple processors accessing the same file, right? Writing to the same file, rather.
Yeah, good point. So this one where you do, maybe the first solution, no, because you loop it through each file several times. But this one, when you do the xarg, yes, the for loop over here, this one can be transformed in xarg, okay?
Yeah.
But probably you're not going to gain because this one, because you know, then you have to merge the file, because this one is going to, because here you can't do this kind of stuff, you know, because you are going to write in a multi-core operation to the same file continuously. I mean, not continuously, but can happen that you are writing by multi-core, by different processor to the same file, and that one will create corruption. So probably this one you can just, now I'm just looking very fast. So probably this one you can do it in a multi-core because you have this option over here. But yes, it's a possibility. You have to be careful about when you always use Xarg to always double check, do I'm writing to the same file by multiple processor? Yes or no? And then, so always be careful about this.
I think the second solution, you would write the same processor because it's looking through each file, right? And they have different dates. Rather the same dates in two different files.
Different files, but what? Yes, but you know, over here, this one can happen that due to that I'm writing to different files, but it's not the same. This one is $1. No, because this one is getting the ID. So over here, you know, is the dates. And these dates can be read in several moments or in the same moment by more CPU and then writing to the same file. So I think this one will fail, but you can double check.
Yeah.
You can double check.
Even I think it will fail. Yeah.
So yeah, do it this one. And then also because it's not going to tell you if it's failed. But then if you can count the number of rows, could be that you get a different number because it's going to be not written, or maybe written something wrong, you know, without ending line or something a bit weird.
Okay.
Yeah.
And another question I had was about using grep. Is it slow? Because I wasn't sure about how many lines are there in the metadata, so I used grep to find where the metadata ends.
Okay, so pay attention about the grep function. So actually over here is always good. So even here, you know, because the grep, this one, for example, you know, that is in the beginning of the line. So, and would be even better, you know, this one. So let me, so this one will help with this. You can eventually longitude. So over here, you know, you give also that probably could be that is going to increase the speed, this one, but I'm not sure. We can check. So now if I put starting with is going to check only the first line, the first, sorry, not the first line, the first column. Okay. Because this one is the one that is checking and is not going to check in all the other columns. So could be that this way is faster than the previous one.
I tried this out actually, and it wasn't a big difference.
So you can test it. It wasn't.
It was not. I would have expected it to be a lot faster, but it really wasn't.
We can do with the time, and we can check.
But in AWK, when I did it with check only the first one or check all of them.
Yeah, sometimes you think that it's faster, but actually it's not. And actually, yeah, are perfect the same. Or maybe you need a bigger data set to see the difference, okay? Anyway, all these tests you can try and see if they are better or not.
Okay. Yeah.
Yeah, actually, this one you can see the difference. Look, this one you can see that it's fast because it's checking only the first line. Sorry, again, the first column. Okay, and then as soon as you find it, then it doesn't go in all the other columns. So a bit of these tricks can help. And actually, AWK does it because you are checking only one line. You know, over here you already implement this system. You say $1 equals, so it's not going to check all the other lines. Okay. Okay, good. Okay, keep this AWK power as a sort of, you know, secret screen to open whenever you you have some big data set. Of course, as we mentioned, messy data set, a table with the comma separator space between. So then it become a really difficult. And you know, and then dealing with Python or with R, that they have implemented already a library on this. But whenever you see something very well structured that is able to squeeze in, really squeeze in or summarize your data with print $1, print $2. This one was already a bit, you know, a bit complex, let's say. But it was a good example to give you the flexibility and to play with a quite big data set. Okay, so this is where you can really make the difference. Once for example, we were doing some big query in Postgres, and the Postgres was taking days, you know. So we do a Postgres dump. So we dump all the Postgres tables in a text file, and then I was just doing the query inside with the AWK in the TXT file, and it was super fast. Really, we went from 2 days to a couple of hours in doing the full analysis of the query. So getting the query and then go back to the Postgres. So the beauty that you can always combine this kind of example. Okay.
Could I ask one more question?
On
the splitting files, like in solution 3?
Yeah.
The way I understood this, right? So because we look at all the files at the same time, they're kind of stacked on top of each other, and then we go through line by line, right? That's what AWK does. So since we only have one of these arrows, the greater than signs, wouldn't it? So we start with the first US1, writes all the first lines into each of these text files, and once we're at US2, wouldn't we overwrite all those files again, so that the final TXT files only have one row in them? Like, or what is that? Like, shouldn't we need 2 arrows in this case for solution 3? And append?
No, yeah, actually, it's something that I also think, but is already appending because it's inside to the same WK function. Okay, so it's appending as a default, you know.
Okay,
appended as a default. Rather, if you create the header before, then you have to append it because there are two independent files, two independent AWK function. So over here there are also other other implementation of how to use the AWK, the links that I was sent to you. So play with that one, try to be creative on these regards, and it's a good data set to play, you know. Or if you have something already, feel free to use it. Okay, any other question in this regards to the AWK or Bash environment that anyone? So try to go back to your Jupyter notebook and start to see what you've done and play. Okay, this one understood, and try to see each single part. Okay, very good. So before to move to the second part of the interpolation, let's have a break. So we come back at the 45. Come back at 45. Okay, let's start to resume. And now for the second part of the class, we are going to review and discuss a bit the lecturing that you were supposed to watch, the temporal interpolation and Landsat image, with a video recording that was listed inside to the syllabus. Okay. So in the syllabus for the assignment for today was to watching the temporal interpolation Landsat image lecturing. This one was part of a work that I was doing in the past, and I implemented this scripting procedure for the full data archive of global level. And I see this one can be a good example of how implementing something real, let's say with a combination of GDAL and PKTOOLS for some study case. So in this case, I don't know if you have any experience with the Landsat image, but there is this Landsat GLAD RD archive built by the Maryland University, Geographic Department of Maryland University, that identify that is a composite, is a mosaic, the full globe, temporal mosaic. Okay, so it's very well done, addressed it very well. So I didn't find any, let's say, big issues in the, in the tiling system and so on. I know the people behind, especially one of the coder. So I find very easy to implement it, the full processing chain without dealing with so much difference and so on. So the beauty of this archive is that he has a very well structured. Each year there is an image that is labeled with a number. Okay, sorry. Each year there are several images that are labeled with this number. Okay, so you have the first column is the year, but then you have all the different 15 days information. Okay, over here. And we are going to deal only with a very small data set in order to not to process the full data archive. Okay, so it's just an example. So in particular, if you consider 2 days, 2 composite days, so you can have the same image that can have a completely different pattern. So over here is completely well visible. Over here you have cloud and you have also stripes. Okay, so this is due to the failing in the sensor in Landsat. And then over here you don't have clouds, but you still have the stripes. Okay, so how we can deal with this one and how we can merge it in such a way. So if we do it a simple build VRT or PK composite and we get everything, we are going to get also the mean, for example, of the cloud and the mean of the stripes. Okay. So how we can deal and how we can inform our merging algorithms that these are clouds or stripes. Okay. So these are the typical characteristics of with the GDAL info. You can see that the pixel size is around 25 kilometers, a bit less, 22 kilometers. So this is in degree resolution, but is the same. I mean, it corresponds more or less to the in meter. Here you can see that there is a different band, okay? And in particular, the 7 band are the typical one from Landsat, okay? So the spectral one, spectral up to 6, and then there is one that is normal brightness temperature, and one in particular, there's a number 8 that is the so-called quality code or quality band, okay? Quality assessment code. The quality assessment code in band number 8 identify different land cover, okay, of the image, or even cloud buffer, shadows, stripes, additional aids, for example, snow, hill shade from the image and so on. So what we are interested in are, of course, land, water. I mean, if it's water, we are also interesting. And snow, also we are interested if there is snow, but whatever is over here means that we don't want to get inside to the mosaic. Okay, so in other words, I'm going to get 1 pixel from here, and be sure that the same pixel in the other image that has been labeled as a cloud in band number 8 is going to be excluded from the composite, okay, from the composite. So this is more or less the typical situation. So by this band, by the band number 8, I can label, okay, my image as a data where my image, or band number as one of these, okay? And all my data, no data, will be the value that will need temporal interpolation through the time, okay? So first of all, I'm going to get what? I'm going to get a composite. So in order to, in order to have a kind of image that we can make a temporal interpolation, I'm going to first having, in the same year, in the same, in the same observation. So over here through the time, I'm going to get a composite, okay? And then I will have a temporal interpolation. So first we will deal it with the same date, with the same time period, let's say January, okay? The first 15 days of January, we will create a composite over here. And this one will allow to merge, to merge these and this. Okay, I'm getting only 3, but it will be all the others. So in fact, 876 is going to be, actually the second one over here, this one. Okay, so all this one I'm going to deal with this one. 8076, 8099, 8090, and the other one. So first one is going to be the temporal composite. So we mentioned in our past that PK composite was the one that was able to deal with this one. And is band number 8, okay, that over here is labeled somewhere here. Band no data 7, because they start from 0, the PK tools. So I'm going to deal with band number 8, call it as a 7, and where all these value have source no data will not be considered. And this number, where they come from, 4, 5, 6, 7, are the ones that are coming from here. 4, 5, 6, 7. Okay, so all these numbers that I list over there are the ones that will be considered no data. Okay, so this is the beauty of, and in particular, somebody actually was asking me, and now we can confirm this one. Okay, in this case, I'm going to use it band no data for the first image, and then again band no data for the second image, and so on. It's going to be always the band 7, the one that is going to be used, but using all these source no data. Okay, and this one will give to me one final TIFF, when again is going to be the mid, and in particular what is going to do the median of all the pixel over here. Quite often you probably know that the median is less sensitive to the outliers. So if there is some issues inside, some pixel that are still outlier, the median is less sensitive compared to the mean. So quite often in our field, we quite often using the median. So again, I'm going to use the median in this vertical domain. So you can try and run this one, and you can get the median. Okay, we can see and open one of these and see what is going to be. So pay attention over here that I'm going to do an XR loop. Okay, in particular over here I'm going to list from 1 to 23, and in particular they are this one, from 1 to 23. Okay, so from here to up to here there are 23 columns. Okay, and this is the typical situation that we have the for loop, a for loop that is translated to xarg. Okay, so the xarg identify the p state for the processor. Okay, so I'm using only 2 processors for now, and over here is going to be my parameters that are going to pass, and the parameter are this one. Okay, I'm going to pass only one parameter. So in other words, the two processors are going to process these two. Then when they finish, they go to these other two. When they finish, they go to other two, and so on. And each one will get care of one. Okay. So the XArg for loop is going to open over here and close it over here. Be careful that here there is a space, and this one is an underscore. Is a bit particular, but is the way to open and close the for loop. So over here you can see that my output is going to be the GDAL translate output. I mean PK composite like GDAL translate, so giving. And you can immediately see that it's going multi-core because it's printing, you know, twice the same information, 10%, 10%, 20%, 20%. So you can see that some are going faster than the other one because it's depending from the image. Okay, so if you have many node data, he has to do the composite between many node data. But the beauty of this is this one, that in the main time that is good is getting the median, is exclude all the pixels that are labeled under the quality flag in all this range from cloud to down over here. Okay, because I just want to be sure that I'm going to interpolate only land or water pixel. Okay, I'm not interested in cloud, affected by cloud. So this is the typical situation where PK composite is really making the difference. So with GDAL, you can do this stuff. And it's quite a unique feature. I didn't find in other features. So you need to build up, also in GRASS, you need to build up something particular to read this in Automatica. And consider that this is the Landsat modify. I mean, is a Landsat image already processed. So they build up this kind of classification band, let's call it like this. But also in Landsat, you have another band that has always flag information about cloud, and also in MODIS. Actually, in MODIS, you have also the so-called quality pixel that they have 4 values from 1 to 4. And identify also how much is contaminated each single pixel by cloud. So using this band as a reference, you can do the composite, avoiding the bad pixel. Okay, is it clear, the concept? Okay, perfect. So I don't know if someone of you was already running the code. Maybe anyone was running already the code? Before Anna, I think she was asking. And did try or not? Not really. Okay, we can try to see if I can open the script, the same script. It should be an exercise, and usually is always, not usually, is always you can have this trick, always use the same file of the web page. So Jupyter Notebook, temporal interpolation. Okay. Okay, so this one we don't need to explain already. Temporal composite. So over here, we can run this one. Let's see if it's work. So you can see probably is running. It doesn't give me any error. So over here is already, you can see that is running and is making this kind of interpolation. Once again, is making, no, it's sorry, not interpolation, composite. Once again, is getting the image in this domain, vertical domain, okay, 1, 2, 3, 4, 5, and 6, and is getting only the pixel labeled as a good from the other band. Okay. So be careful about this one. Now, actually, I should have done something, because now it should work in parallel, but probably it's not working parallel because I have, maybe I set it, I don't remember. Let me see. Here you can, look at this one. Also, this one is another command. So if you do, let me open another new window. If you do htop, okay, you get your CPU running. Actually, I didn't run as a multi-core. I should have increasing my CPU. But this one is giving to you the CPU value, okay? htop. If you have more than one CPU, now I didn't set up in my virtual machine, you should have 2 lines, okay? In that case, the 2 lines should be working together. Actually, now I'm not sure what it's doing. It's probably, yeah, I think it's doing 1 by 1, even if I put 2 over here. And this is where you can play. Look, he's doing, actually he was doing 2. I don't know how, but he was doing 2 by 2. You can see the printing. And now we can go over here. This last line was due to that I was also getting the, you know, the composite of band 8. And actually band 8 and band 7. So actually over here, this one, this GDAL translated nothing else, and it select only the spectral band that I need. So now in this case, if I go back to my terminal, I can see the median. So we can see how many median he did. So he did, you know, for each of the 623 band, he get the each one of the 23 observation, you get the median of the 6 bands. So let's open one of them. Of course, with OpenEV, we are going to check only the first 3 band in RGB. So these are the interpolated one, okay? So you can see they're pretty good. Probably during the winter, during the summer will be slightly better than during the winter. So we can see, let's see another one. Here you have. So what does it mean? That over here, you have all the image in this constraint. Okay. So during the summer, you know, you have one of these will have data and it's fine. You can get it. Okay. Rather during the winter could be that several image, they have clouds or stripes, okay? And the only one that remain are the pixel with the good pixel. So these one are the one that later on in the temporal domain, we need to interpolate, okay? Is it clear, the concept? So over here, you can see the image after the interpolation, after the composite. I think I make a plot, edit a plot. So look, I open, no, it's not the same, but it's the same concept. So the temporal interpolation, okay, before to go in the temporal interpolation, let's see this plotting. So over here, you can see that the image, the 23 image, okay, each one of these, they could have no data value because during the winter it was quite often present no data, okay? And now in the interpolation, the meaning of the interpolation, we are going to refill this no data based on the temporal domain. So based on the previous observation and after observation in according to different algorithms, okay? So let's go back. So in other words, one of these is this one, okay? Before, that's why, before the interpolation. Okay, so at this point, we can run the temporal in interpolation. This one, you can do it for each single band, of course. Band 1 of all the image need to be interpolated. Band 2 of all the image need to be interpolated. for simplicity, we do only band 1.
Giuseppe, can I ask a quick question?
Please.
When you're saying that you're interpolating based on the previous one, what are you referring to? The one that is that would be the month before, or the day before in another year?
So we have 23 observation. We have 23 observation each single year. Okay, so if you go here, actually, let's see here, that is in one single temporal. Yeah, it's one single line, it's easy to read. So over here, we have 23 observation in one single year, okay? So you have here, these are the 23 observation. 2017, you have 23 observation image, okay? So by the first composite that we do the median in this one.
Right.
So the January, let's call it January. January, first week of January, we do it all the composite in this line, and then in this one, and then in this one. So we will have 23 observation for from 2017 to 2022.
Right.
Okay. But even we still have this composite in the temporal in this domain, we still have no data. So we want a full pattern, a full gap filling of this no data. And this one are the no data. So at this point, we have 23 images. So we are going to do the temporal interpolation with the information that we had before and after, or in the 23 observation. Okay.
Okay. Yeah. Okay.
Okay, clear. That's why for only one band, so now consider the one band, we have this plot that identify before the interpolation. After the composite and before the interpolation, we still have a lot of no data, especially in winter. Okay, these are not 23, but they are 16 just for plotting issues. Okay, plotting reason. And this temporal interpolation, of course, you can do with different algorithms. Okay, this one, temporal interpolation. Yes. 1 second. This is the composite. Yeah. So the temporal interpolation can be done with different algorithms. And in the video, there is also a very well explanation from a mathematical point from Lunzu Shen, the other teacher, that the mathematician expert, that he can explain to you very well how the different interpolation technique are different from a mathematical perspective. And over here is where we do the composite. So in particular, now we need to work horizontal. Before we were working vertically for each single, in January, all the January, in February, all the February, and so on. Now we need to work in horizontal. So in order to work horizontal, we need to build up, a VRT in the 23 dimension, okay, as a separate. So it should be somewhere over here, the separate. Source node data where. No, over here as a no, here is just extracting. Sorry, here is just extracting one particular band, okay, and over here is building one particular band because we are working only with band 1, and here we are building the VRT in the temporal domain. Okay. Now that we have the VRT as a separate, so as a single band, so you can here to see the separate. So we have the 23 information in line. Now we can do the gap PK filter with a Kima spline. Okay. And then we can do also the same, but rather than the Kima spline, the Stefan spline. Okay. And this one is able to setting up based on the image that has no data. So all this black area is going to be interpolated. Okay. So let's see the plot, and that probably is going to be easier to see. So
I had a quick question on this.
Yeah.
So you in the video you mentioned that you replicate the data 3 times so that it's like a loop, right? So you don't have these edge cases.
Perfect.
But so you do this out of convenience, right? Because only necessary is only depending on the algorithm 1, 2, 3, or 4 of these observations, right? You wouldn't have to replicate the full data set. Is that right?
Yeah, good. Yeah, good point. Yeah,
Okay.
really good point. But frankly speaking, I didn't know because there was not any flag how far in the time was going to read the previous data set, and also because later on they were need to more information, and so it was easier to build up completely the same. Okay.
Yeah.
So good point. Was going to easier to build up completely the same. But this is the final. I mean, let's go to the result. So you can see that each single image is going to be refilled where is white over here. It's going to refill it with the information coming from the different algorithm. And let's see the plot in this way. Then we go back. Okay. So this one is the one that probably the other girl, Anna, was mentioned that she cannot run it, but this is just for making the plot properly because I did last year. So probably there is some issues with one liter. So you can see the plot over here. So here you can see, let's see what we are doing in a practical context. So you have the information when the original point. Here you have information for one single pixel, of course. Here you have information, okay, of the pixel value. Whatever is down over here means that is no data value. So over here is no data value. And this is the one that we are going to refill. And as you can see, perfect in the same direction, we were using the information from here to here and also from here from the replication to refill this pixel over here. And the same for the other. So you could see that the different algorithm can produce different solution, okay? Slight different solution. And these two pixels, these two algorithms, Stefan and Akima, are the ones that are over here reported as over here, Akima spline and Stefan spline. Here is just a reselection due to that we were replicated, of course, also before and after the replication where they were doing the temporal interpolation, but we are interested in only the center one, okay? So we were just reselect the central part. And of course, there are some area that are they have a different, more evident gap, okay? And of course, the different interpolation technique can produce slightly different result, okay? In the explanation of Lunzu Shen in the video, you can see that the Akima is a bit more tied to the previous one rather than Stefan node. So one is more sensible to the outlier and the other one not. So over here, you can see also that, of course, there will be difference. Okay, how we can check, for example, which one is better? Can we check or how you would do a kind of validation procedure?
It comes up in the video too. You could remove a data point where you know it, run the algorithm and see which one's closer.
Yeah, and then see. So of course over here you don't have the pixel, so you can't validate. Okay, but what you can do it is remove this one, for example, the cross. You will have an estimation between the two, and then you can calculate the root mean square error. I mean the difference between the two estimation and the pixel that you remove it. Okay. Also here there is with my PhD student we did. I don't know if he's over here. It's read. No, but if you Google it, there is. I didn't write, but there is a gap filling. We have a gap filling article on this, and he presents kind of result on this. Okay. So this is the way of to show how you can use it, you know, GDAL and PKTOOLS to not only in the spatial domain, but also in the temporal domain for this gap filling, okay? For, we say all the time, moving window algorithm and so on. So it's very, it took me a while to really understand all the flag, and but this one give you a really good overview of how to use it in this contest. Yeah, you can, over here you can assess in the temporal interpolation, so you can see that the value that has been filled up for one particular, of course, for one particular pixel. Indeed, I do the GDAL location info, and I do the plotting over here. Another one is also the Savinsky-Golay smoothing filter. Okay, is another way of interpolation that you can go and read. Actually, this one they have, if you Google this one, they have a very nice visualization in Wikipedia that really show you what does the Savinsky-Golay. Yeah, take a while. So this is, oops. And you can see, and you can also interpolate, you know, here you can see the Savinsky-Golay is a bit more close to this point. Okay, so you can do a prediction on the same point also, because, for example, this one I'm predicting also on that point, so it's smoothing out all the, you can see over here, you have the observation over here that can be temporal fluctuation, and you want a smoothing function through the through your observation. In our case, you know, actually no, in this case, you know, the continuous line is your observation. So let's say our pixel, and then you want to do an estimation that is smoothing out, of course, eventually some outlier. And this one is what we are doing over here. And you can see immediately over here, sorry, here. And you can see immediately that we are estimating not only where there was no data, but also where there was the observation, because it's smoothing out everything. Okay, so it's very very well procedure. Then there is also the wavelet prediction that is pretty the same, always in the same with the PK filter, with filter analysis, but we have one more estimation with the wavelet prediction. Okay, so try to, this is to really like a summary of the potential of these tools, okay? No, not only in the spatial domain, but also in the temporal domain. As I mentioned several times, I use it quite a lot for standardize all my raster file, mainly. Okay, I always, my 99% of my process is raster file, really doing with vector file a few times. And then whenever they are super standardized in terms of pixel resolution, then I can enter in Python, I can enter in R, I can do this kind of PK comp filtering in the temporal domain, but always be sure that everything is under the same dataset constraint, okay? Because if not, then the problem come out, and then you don't know if you know your modeling error is due to some pixel shift, or maybe just the, you know, the limitation of your modeling performance. So once again, you can find the video recording in the, yes, in the lecture of this, yeah. Yeah, video recording here. You can find the video recording here, the link, if you want to re-listen. Okay. So anyone is thinking, have done some kind of working with satellite, and not only with the Landsat, but even with the most simple PK composite, because over here is where you really see the difference. And you were trying to combine based on a quality flag layers, maybe Olivia, no? And so you were nodding before.
Yeah, it makes sense to me. I'm not directly working with any like LiDAR right now, but the concepts make sense to me.
Yeah, probably Sentinel. I didn't work so much with Sentinel. Probably also Sentinel as a quality flag band that you can use it. The problem is Sentinel is very, very heavy, and actually Francesco, the guy that is talking next time, on Thursday, is not going to talk about Sentinel now, but when you come to Matera, and Matera is going to have a Google Earth Engine 1 hour, 2 hour lecture on the use for Sentinel analysis, because he always do the pre-processing in Google Earth Engine, and then when the Sentinel is ready to be composite and so on, then he download it and he use it. Because they are quite heavy for the downloading, storing, and especially if you work with, each single image, I think it's 2 giga or even more, like 6, 7 giga. So it's very heavy to process.
One question I did have was for the bands for like the quality control flags. Is there like an algorithm or something that goes through the image to like classify the pixels, or how do they get classified?
Well, perfect. So over here in the GLAD-RD, sorry, here the GLAD-RD is already pre-composite database of Landsat images that are being classified based on classification tree, and identify these classes over here. Okay, the Landsat as an origin, he has only the quality flag that identify cloud, if I remember correctly, cloud, hillshade, and also snow, these 3 flags. And then they do a second analysis to identify all the rest. Okay, so and then they pull out this nice quality code assessment to do. And Antonio is going to cover in the machine learning domain. So as you know, any kind of statistical modeling can be divided into big parts. One for classification, the other one for regression. Classification identify classes, and regression identify continuous field estimation or correlation. Okay, so we are going to use it. We are going to have an example of a deep example of regression, because it's a bit more easier to grasp, but the same concept can be useful transformed for classification. And Antonio is going to go deep also in the regression analysis, but also point to some classification aspect. For PKTOOLS has 2 algorithms, KNN, neural network for classification, and also support vector machine. You can see inside here you have the, let me close this one. You can have the, I think it's PK, the ANN. This one is support vector machine, and this one is the so this should be this one, the support vector machine. And so I don't have in my web page a support vector machine, but actually, if you are interested, we are going to have Peter in 2 weeks coming, the developer of, so it's something that you can ask a little example how to use PKTOOLS for classification if you are interested in this. Actually, he was mentioning his presentation. If you want something in particular, let me know that I can build a little example. So feel free to contact him There are the link in the syllabus with the email and so on. Okay. Okay. Any other question?
I did have a question, but maybe it's more for Longzhu. Like he was mentioning that we can use wavelet filters if some properties are fulfilled, but he didn't go into what these properties are. I was wondering how one tests for them or should test for them. And then also there's like, I looked into wavelets before.
I think it was,
yeah.
I think it was mentioned about some statistical properties like normal distributed and non-normal distributed, but I'm not sure. Maybe it's a question that you can ask him. He will be happy to reply on this. Yeah.
And then also for wavelets, I've looked into this before. There's like a lot of choice as to which wavelet to use. And I was wondering if there's some, I don't know, best practices or decision trees, flowcharts on which ones to use, or is this like you have to look at your data kind of question?
Yeah, another question for Lonzo, also this one. Yeah.
Yes, I figured.
Yeah, there are different wavelet and there are also different band of the wavelet that you can select. I don't know if you have all these flagged inside to PKTools or if there is only one function for the inside to the wavelet. Frankly speaking, I don't know which one is implementing. So I think between Lonzo and Peter, these are questions that both of them, they can rise up. Yeah. Yeah, Lonzo for sure, he will tell you from a mathematical perspective, and Peter, he can tell you from which one he implemented and maybe why. Yeah.
Thank you.
Good. Okay. Mm-hmm. Okay. So, is there any?
May I ask?
Yes, please.
May I ask is that like for our our geo data set, for example, maybe you combine different different resolution, like maybe like the machine learning project we were talking about, the climate and the hydrology, maybe you have different spatial scale. So it's good to use use GDAL to resample and make it into a standardized resolution before proceeding to the machine learning part, right? It is good that we try to standardize. And may I ask?
Yes, you know,
and yes, like when the like for the grass, it is after this part, right? The grass. When do we use the grass?
Okay, so for the first one, yes. So of course, it's better to enter inside to Python with all the resolution and changing resolution already done. Let's say already set up. In this way, all your TIFF are ready for the machine learning computation for your modeling part. You know, in the changing pixel resolution, there is a very huge way of how to do it. I always try to say, do not go so much. I mean, don't go from 1 degree to 90 meter resolution, you know, neither in both direction, because you will have a lot of inside time. But you know, between 90 meter, 1 kilometer, between 1 kilometer to 5. So these are the kind of range that you are allowed to interpolate. And then of course, when you go down, there are also some kind of more in the climate science. There are more downscaling statistical interpolation, they call it. That you can do also downscaling statistical interpolation, a sort of regression using auxiliary layers. So it's really depending what you have to do, how to interpolate this point. How to interpolate this pixel. Concerning the grass, we don't have a real session of grass inside to the classes, okay? But there are video, okay? There are video lecture, and in particular, there are video lecture from last year. So feel free to use it. And now actually is a good moment in the sense, and actually in a good moment because you had finished. I mean, you guys have already mastering the bash, and grass is the main language, is the bash command, is in the bash terminal, okay? So it will be quite straight to go and use it. Over here you have over here you have a web seminar, Introduction to GIS, that can tell you the main structure of the grass, because it's quite complex to understand in the beginning. And then below over here you have two session grass introduction and the using of grass for stream network delineation. And this one, I think I have video, but I think I need to there is not yet a link, so I will be sure that the video is there. I think I teach several times, so probably one. Yeah, over here there is no video, but I will be sure that there is video. Anyway, with the grass introduction, then the rest will come really straight, you know. So I would say start with a grass introduction, the web seminar, okay? This one, Introduction to GRASS web seminar.
What function should we leave it to GRASS to operate, and what kind of function should we use the PK tools and the GDAL to function? Like what kind of operation should we use GRASS? Like maybe resampling and filtering could use a PK tool.
Yeah, so in yes. No, in my field. So no, in our case, as I mentioned some other times, also for GRASS, whatever is, can anyone hear me? Yeah.
I think there's just a delay, but we can hear you.
Yeah.
Oh, okay, perfect. Thank you. So whatever also for GRASS is valid, the same principle. Try to standardize all your data set in terms of, you know, pixel resolution, tiling system, because for example, even a digital elevation model, you download the digital elevation model, you want to be sure that all the pixels are on in the same size, all the tiling system, and then when your data set, your raster file are really good in shape, then you import it inside GRASS, and inside GRASS you do, so in my field, flow accumulation, stream delineation, or maybe image segmentation for satellite image, okay? So whatever you do it with the pre-processing that you learn so far in GDAL and PKTOOLS, they are also useful before to enter inside GRASS. Okay, someone?
Okay, thank you very much. So we'll work on these two first.
Okay, perfect.
Yeah. Thank you.
Perfect. Yeah.
Yes, and is it possible to combine the commands from Bash, from the PKTOOLS, and from the GRASS in the same script? For example, just like we did earlier, like combining Bash and other commands in the same script. So to introduce some GRASS commands also, or it is only possible to run they separately?
No, actually it's very common. It's very common to have, because the GRASS is directly as a bash, you know. So it's very common to have a few lines of GRASS and one of GDAL and a few lines of GRASS. Rather, in R in Python, you have to really open a new environment. But in the GRASS environment, in the GRASS is in GDAL, is in bash. So you can call each single line like we were doing from GDAL and PKTOOL, can be another one with GRASS. Okay.
So GRASS is then also one indexed.
Are you there?
Yeah. Okay. Thank you.
I have my student from Nigeria. I don't know, Olatin. Is Olatin on the? So he never used grass, and I just showed him one script, and in 2 days he was just producing scripts. So because it's when you have the basic as a bash command, and you have the GDAL and PK setting plus a web seminar, then it's really easy to go and implement it. You know. So as I mentioned, all the pre-processing is good to have it in GDAL, also because it's a bit easier. You know, you can open immediately with the OpenEV, see what is going on, and then later on you can just use it, the grass command, to do something very particular. Okay, like I mentioned, hydrological analysis, or for example, clamping. There is, when you give an ID of each single raster polygon. Okay, so you have, for example, you have a land cover, and do you want that each single class that is isolated from the others become a polygon with an ID? That one is called clamping. There is no command in GDAL and PKTOOLS that does the clamping, but in GRASS, yes. So you prepare your data set, you import in GRASS, and you can run a clamping operation. Okay. Okay. Some other question? Okay, probably not. So I'm going to share just one moment today. Let's see, the syllabus. Anyway, the syllabus, we have another lecture. We have another lecture for from next week. Sorry, not next week, on Thursday, from Francesco, that is going to show you rasterio in Python. So now we enter in the Python, let's say in the Python world, and from now on we will use Python, but without forget bash. Okay, so we will run a few times some command in bash, and then we have next week we have the catch-up session. Okay, so you can see, okay, without sharing because my internet is a bit slow today, but you can see that in the syllabus we have it lecture after lecture 8 we have session 1, catch-up session 1, catch-up session 2. So it's next week. So we are going to meet next week just for quality Q&A, question and discussion. Maybe Samuel want to already see the video for GRASS, and he want to ask some question for GRASS, all this kind of interaction between us in order to proceed and to even get stronger in what you have learned so far. Okay, so these are really catch-up session if somebody was a bit behind. So this is the time to catch up in terms of assimilation in real trial. Okay, so Alex, feel free to come, try as much you can, and come with question, and the same for everybody. Okay. Okay. So from my side, it's all for today. I don't know if you have additional question or some other point to discuss it. Okay. If not, we can resume, and we can meet next week. Sorry, again, Thursday.